Question 4, this is from a GCSE paper. It says figure 1.1 shows a liquid in glass thermometer. In the process of making the thermometer, the scale divisions were equally spaced. What assumption was made about the liquid? So the one that we probably want to go for is that it expands linearly. So expanding linearly means that each temperature interval, each degree Celsius will cause the same expansion of the liquid. If you've put that in your own words, that's fine. 2, suggest 2 changes to the thermometer that would require the spacing of the scale divisions to be larger. So I think the most obvious 2 are having a larger bulb, putting more liquid in to expand effectively, or having a thinner tube, a thinner bore in the middle of the thermometer. If you didn't write larger bulb, you could just write more liquid. I think if you're going to put more liquid in, then it needs a larger bulb, but it does allow more liquid. The last would be to change the liquid, so to a liquid with greater expansivity would also work as a change. As a result of the changes in 2, what other change is needed to enable the thermometer to be used for the same temperature range? So range here meaning the difference between the smallest and the largest value on our thermometer. So if we want the spacing of the scale divisions to be larger, but the temperature range to remain the same, then the thermometer is going to need to be longer. Last part, expansion of a liquid is an example of a physical property that may be used to measure temperature. State 2 other physical properties that may be used to measure temperature. So there's actually lots of pairs we could put in here. We could do something to do with an electrical circuit. So that might be the resistance of a wire, might be the resistance of a thermistor, would be even better than the resistance of a wire. We could talk about conductance instead of resistance. We could use something called a thermocouple that you might have heard of before. If we were using a thermocouple, we're going to measure either the voltage or the current on the thermocouple. We might look at something to do with gas. We looked at an experiment to do with gases recently, so we might look at the volume or the pressure of a gas sample to measure the temperature. There are lots of other things you could use though. So the color of a metal might be used in some cases. If we're able to measure the infrared radiation being emitted by the thing that's hot, then we might be able to measure the amount or the frequency or the wavelength of radiation from that object. If you've ever seen one of those infrared temperature guns, that's what they do. If you've ever used a thermometer that displays by the numbers appearing and disappearing as the temperature changes, that's to do with sort of liquid crystals. So the color of liquid crystals can be made to change at different temperatures. We could use a piece of metal, a solid lump of metal, and measure how much it expands. And then by extension, you might have come across an object called a bimetallic strip. So that's 2 types of metal clamped together so that they bend to one side or the other as one of the metals expands more than the other.